Do you love books? Do you wish you could hear some insights straight from the author themselves? Join Sam Hankin, your host, as he interviews top-selling book authors and dives into interesting and unforgettable discussions here at The Avid Reader.
Hi, everyone. Welcome to another edition of The Avid Reader, brought to you by Wellington Square Bookshop. Today, our guest is Keith Cooper. He's the author of Amazing Worlds of Science Fiction and Science Fact. It was published by Reaction Books, which is a great publishing company. Take a look at their website. It's published earlier this year. Keith is a science journalist who's written for New Scientist, Physics World, Sky and Telescope, among many others. He has edited Astronomy Now magazine for nearly 20 years. His previous work was The Contact Paradox, which could be read easily in tandem with this book. So since I was 8, I've been a rabid science fiction reader, from Arthur C. Clarke to Robert Heinlein, H.G. Wells. I've interviewed Andy Weir a couple of times talking about hard science fiction. Frank Herbert, H.G. Wells, Ursula Le Guin, all of whom are fortuitously mentioned in this book. So like I said, when I looked at the bibliography of the book, and I hate to use literal when it should be figurative, but the books listed are, for me, literally the stuff that dreams are made of. The search for extraterrestrial intelligence is ongoing and has yet to reveal any. But sometimes I feel there really isn't that much here either. In any event, it's the journey that matters. And in many ways, those who search today are standing on the shoulders of giants, not Newton or Einstein's, but Asimov's, Bradbury's, and Simac's. It's funny, though, as I write this, which I was writing it, I was also chatting with ChatGPT. And it was about Simac and the book Way Station, which is one of my favorites. And I got to thinking about computer on Star Trek, and I realized that our LLMs today are way smarter and more interesting than she was. I mean, you can say reactor core failure imminent, or you can say, hey guys, I think the reactor is about to explode. Maybe you should get down there on the double before the ship explodes to hell. And even the doors sliding open in Star Trek, you know, it seems old fashioned now, but it was predicting a future that hasn't even yet occurred chronologically. But anyway, Keith provides a window, a way station, if you will, to go back to Simac, that connects the science fiction that we love with the newly discovered exoplanets where we seek life, from the rocky super Earths to the snowballs revolving around 1, 2, or even 3 stars, locked or not in tidal configurations where those aliens we can't yet observe watch 2 sunsets like Luke does on Tatooine. So welcome, Keith. Thanks so much for joining us.
It's a pleasure to meet you, Sam. Thank you for inviting me.
So I was thinking of a good way to begin. I was thinking maybe go back to when you were a kid. And how was it that your obvious fascination with science fiction led you into the real world of science? And what's your Terminator or Twilight area that allows you to join the two?
You know, I think, to me, they come in tandem. My dad likes astronomy. He's an amateur astronomer, stargazing with his telescope. So from a very young age, he was taking me out into the backyard, showing me the stars, pointing out the constellations. And at the same time, I was, you know, aged 4, maybe 5. You know, I was introduced to the Star Wars films on VHS from the rental shop, back in the day when they had video rental shops. You know, a lot of the kids' cartoons at the time were very science fiction heavy, Transformers and Masters of the Universe and things like that. Star Trek, my introduction to Star Trek would have been the original series before the Next Generation was even made. I remember sat with my dad on the sofa waiting for my mum to come home from work, you know, in the evening, and BBC had repeats of the original Star Trek show. And that's when I first saw Star Trek at the age of 5 or 6. I definitely remember the episode Arena where Kirk is fighting the Gorn. And then the Next Generation came along. And all this time, I remember most 8-year-olds want to become a sports star or a fighter pilot or whatever. When I was 8, I wanted to be an astronomer. I wanted to sit in one of the big observatories on Hawaii and look through a telescope. And this is what I thought at the time. You know, astronomers still made discoveries by physically looking through telescopes. So they've always come in tandem. They've always been connected to me. So when I came to write Amazing Worlds, it just seemed natural to connect the real exoplanets, the real planets that we're discovering around other stars out there in the universe, with the planets that are presented in science fiction, and which I feel like, you know, that I have been stepping on, you know, for so many years, reading, you know, science fiction novels and films, TV shows. It just seemed natural to put them together as a way of, well, I think fiction is a lens that we're able to look at the real scientific discoveries through. But vice versa, I found that the real discoveries are also giving us insights into the fictional worlds and the writing behind them. So yeah, throughout the whole process, they've always been melded together in my mind.
I think one of the really good things you do in the book is, and I talked about it a little bit in the introduction, is like the authors like Ursula Le Guin, Arthur C. Clarke. You talk about almost like their prescience, like they actually predicted almost exactly what would happen. And then you go back to the science now based on what their genius envisioned. That was very eye-opening.
I think, I mean, there's a little bit of a caveat there just from my own personal ignorance. I don't know what was in the scientific literature when people like Clarke and Le Guin were writing their stories, and whether they went to the scientific literature and borrowed ideas from it, as science fiction writers do today. So I don't know, and there could be some aspect of that, but you know, even the fact that they were able to do that and realize what was important. I mean, especially in the 60s was a time when, you know, we were starting to become more environmentally aware anyway. And part of that is imagining what the Earth would be like if conditions were different. And then that takes us to thinking about other planets as well. So I think there was a little bit of that in things as well back then. But yeah, I certainly, for the public, those, you know, classic science fiction writers presented a lot of these ideas for the first time.
I guess then we should go back to SETI. And for those of us who don't know that much about it, talk about, you know, how it first happened in Arecibo and Kepler, and how that led you to an understanding of what is and what could be out there.
Sure. I mean, once upon a time, people thought the Earth was the center of the universe. We had a geocentric model where everything revolved around the Earth, and up there in the stars was the domain of the angels, and then all the life was down here on terra firma. So I think the big change was Copernicanism, the realization that Earth isn't the center of the universe, that those stars out there are just like our sun. So if they're like our sun, and our sun has planets with life on, could those stars also have planets with life on? And, you know, we weren't really able to test that idea until middle of the 20th century, the advent of radio. And astronomers realized that radio waves are the perfect means of communicating across light years. So Frank Drake, who's the father of SETI, really, he was a radio astronomer in the United States. He was the first to do a radio search, Project Ozma, in 1960. He used the telescopes at Green Bank. And that really kick-started the modern search for extraterrestrial intelligence. It inspired Russian, Soviet astronomers to develop their own SETI program. So the idea is to look for intelligent life communicating, trying to communicate to us or to each other, and we eavesdrop on them. We haven't found anything yet, and different people draw different conclusions from that. Of course, searching for radio waves and radio communication, you know, that leaves out all the other forms of life that don't have technology, that don't or aren't interested in communicating. And then that naturally brings us on to exoplanets as well, you know, because if there's life out there, it must have somewhere to live. So should we be looking for planets just like Earth that would possess life just like life here is on Earth? Or should we be looking for other kinds of planets that could be habitable in certain niches and support certain kinds of life and not others? And that led to a whole scientific field called astrobiology, which some people think is a strange subject, because how can scientists study the biology of aliens when nobody has discovered anything? But it's about the science of how life originated and, you know, where it could exist, and then therefore where we should be looking to find it.
So when someone who's a neophyte in this looks at you and says, well, how the heck can you see a planet with a star, even a star orbiting as close as 4 light years away, Proxima Centauri, which is a triple system? And how can you possibly, what is the mechanism, what is the scientific method of determining whether a star has a planet orbiting about it, and, you know, how you can block out the star, how you can determine the transits, you know, just basic.
Yeah, sure. Well, if somebody asked that question, how on earth can you see a planet around another star, and they ask that with incredulity, then they're absolutely right. It's very difficult. So much so that the first planets weren't discovered until the 1990s. And this is something I comment on in Amazing Worlds, this demarcation between the period when we didn't know whether other stars had planets. There were some theories that our solar system was a complete fluke, and that other stars would be barren and wouldn't have worlds orbiting them. But, you know, even though there was that ambiguity about whether other planets exist around other stars, that didn't stop science fiction. You know, when Captain Kirk was boldly going to worlds, we didn't even know if worlds existed around other stars. So that was a bit of a leap of faith. So how did we discover exoplanets? You're right that they are very far away, and they're pretty small in comparison to the distance at which they are. So most of the exoplanets we cannot see directly. Sometimes you see these wonderful artist impressions to coincide with a discovery by NASA or whatever. And that's exactly all they are. They're artist impressions. We don't have a picture of these worlds. So what are we detecting then? The first planets were around sun-like stars were discovered by detecting the wobble of the star as it orbits the center of mass between itself and its planet. Now that sounds very technical. Think of a seesaw, and there's an adult on one side and a child on the other. And in this case, the adult represents the sun, the larger body in the system, and the child represents a planet, the smaller body. And if you wanted to balance them, so they were both, so the seesaw was straight, you'd find like a pivot point between them. That pivot point is their center of mass. And it's similar in planetary systems, where there's a center of mass of the system, and everything revolves around that center of mass. Now, normally the center of mass is very close to the star. Sometimes it's actually inside the star, but it's not bang center inside the star. So the star wobbles around the center of mass, and we can see that wobble in the Doppler shift of its light. So if you think of a police siren, as the police car races towards you and then races away, and the siren raises in pitch, then decreases again. That's a Doppler shift in sound waves. We see something similar in light. Light can be Doppler shifted. If something's coming towards us, those light waves are compressed towards bluer wavelengths. That's blue shift. And when something's moving away from us, the light waves are stretched out into redder wavelengths, and that's what we call redshift. So as this star is orbiting the center of mass between itself and the planets, its light is being redshifted and blue shifted by minute amounts, equivalent to, maybe 10 or 20 meters per second. And our instruments are sensitive enough to be able to detect this wobble, this slight Doppler shifted motion. So the bigger the planet orbiting a star, the larger the wobble, the larger the Doppler shift. So that's one way of finding exoplanets. It's very indirect. Another popular way is the transit method. So it only works if we're aligned edge on with this alien planetary system. Every time a planet goes in front of its star, it blocks some of the star's light from our point of view. So if we see a dip in light 2, 3, 4 times a regular period, equating to its orbital period around the star, then we can deduce that there must be something orbiting that star and blocking its light. It's not a very big dip. A Jupiter-sized planet might block about 1% of a sun-like star's light, and a planet like Earth would block about 0.1%, I think it is. So these are really tiny amounts, but astronomers are still able to detect them. Again, it's kind of indirect. You might want to think of it as, we don't see the silhouette of the planet against the star, but it's the same principle. For the planets that we have directly imaged, these tend to be quite far out from your star. You mentioned there that we have to block out the star's light because the glare is so much that we can't see anything close to them. So these tend to be very far out, maybe the distance of Pluto from the sun. They're very big, and they've just formed. They might only be a few million years old, and therefore they're still quite warm from their formation and radiating an infrared light. So they stand out in infrared, and we've maybe observed maybe about 100 of those. But it's really cool. We've seen, but with this time-lapse images where they've taken images sort of every year, and you can see maybe 2 or 3 planets slowly orbiting their star, and it's a wonderful example of Kepler's laws of planetary motion.
I know that's one of the most fascinating things, and online you can actually see the transit in video. It's almost imaginative. I like the woman who, because you were saying it has to be directly facing onto it, like Saturn's rings, I guess. But I like the woman who runs the simulations of all the things that we cannot possibly see.
Yeah. And this is the thing. It's when astronomers were first looking for exoplanets, they were expecting planetary systems like our own. So you have the little planets closer to the sun, the little rocky planets, as in the case of our solar system, where you've got Mercury, Venus, Earth, and Mars. They're closer to the sun. And you have the gas giants further out, Jupiter, Saturn, Uranus, and Neptune. And that was kind of baked into the models of how the planets formed, that all the heavier rocky materials, the silicate materials, concentrated closer to the sun where the gravity was stronger, and the gases and the ices were further out. So that's what we expected to find. And it was a big shock when astronomers weren't looking for this, but the first planet found was what we call a hot Jupiter. It's like a gas giant like Jupiter, but it's right on its star's doorstep, just like a couple of million kilometers away. Earth is 150 million kilometers from the sun, so that's the context. And I was like, how the heck did this giant planet get there? That shouldn't have happened. And it about 10 years for them to figure out that the planet must have formed further out and migrated in. But the point is, it wasn't what we were expecting. And it's difficult to find things when you're not expecting to find them. How do you search for something that you don't know, you haven't even thought of? So I think the person you're referring to is Jessie Christiansen at Caltech. And she models all kinds of possible planetary systems to see what physics tells us could exist. And then astronomers can go and start looking for these and see if they really could exist, or whether they would only be fictional.
One of the things that surprised me, and I had no idea, and I think it actually surprised you at one point, is that we may find that a majority of the planets that we're looking for orbit around red dwarfs. And also the fact that red dwarfs will be here. I never realized that either. A lot longer than most of the other stuff that's out there.
Yeah. It's crazy to think that so red dwarf is a star that has between 10% and 50% of the mass of our sun. They're very small, and they make up about 3/4 of all the stars in the universe. The universe seems to favor forming these small stars. It's the massive stars that are rare, and even our sun is relatively rare. But yeah, you think a small star would use up all its hydrogen fuel faster because it doesn't have as much, but it actually uses it up slowly because the nuclear reactions inside the star are controlled by the temperature and the pressure within the star's core. And that is controlled by the force of all the star's mass trying to pull down via gravity onto the core. More massive stars have more mass, so there's more gravity trying to concentrate it all down into the core, and the temperature rises much higher than in the core of a red dwarf, and more massive stars use up all their hydrogen much more quickly, and they're the ones that explode as supernovae. Well, red dwarfs, they just trickle along. They don't need to use up much energy to retain their structure. They can survive for a trillion years, maybe more. our sun will be gone in the next 5 billion years, but the Proxima Centauri, the closest star to our sun, is a red dwarf star that will exist far into the future. So if life wants to have a very long future, if it doesn't want to have to keep moving planets every time its star burns out, then the red dwarf would be a really good location to go to.
And the other interesting thing I found was that you explained was that because it's a red dwarf, the planets will orbit much closer, as close as Mercury orbits the sun, or even closer. And that the analogy you gave was really good, that traveling from one planet to one planet might be just equivalent as the Apollo space program.
Quite literally. So yeah, a red dwarf, as a red dwarf is a scaled down star, then its planetary system is also scaled down. We found lots of planets around red dwarfs. A famous one that your listeners may have heard of is TRAPPIST-1. This is a planetary system about 40 light years away. It's got 7 planets, and some of them are literally as close to each other as the Earth is to the moon. It's crazy how they can get that close. You could literally see cities on each planet, you know, if there were cities there. And as you say, getting from one planet to another would be, you know, relatively simple, just like going to the moon. But there is a downside to such worlds, which is that they would be what we call tidally locked. Basically, their rotation has become synchronized to their star. So they still rotate, but the amount of time it takes for them to rotate on their axis, what we call a day on Earth, is the same amount of time as it takes for them to complete an orbit around their star, what we would call a year. So like the moon always shows the same face to Earth, these planets would also only show their same face to their star. So you would have one hemisphere in constant daylight and the other hemisphere in eternal darkness. And that might make living there interesting for all kinds of reasons, from climate to just, you know, having no sunrise and no sunset, no progression of time. It would be a very strange environment to live in, but I guess there's no reason that life couldn't evolve in such a world.
I did read one science fiction book once where the Terminator kind of moved around the planet. And so the inhabitants were like gypsies. They just moved along with the Terminator. I can't remember what the book was.
Was that, I think there was a book by Kim Stanley Robinson.
Yeah.
And it was set on Mercury. So Mercury isn't tidally locked, but it does have this funny, it spins on its axis 3 times for every 2 orbits that it makes of the sun, if I remember. So the Terminator moves very slowly around the planet. The days are very long there. And yeah, from what I remember, it's like a convoy, isn't it, of almost mobile city-states that move and keep, because Mercury is a very hot planet. And on the day side, you know, the facing the full brunt of the sun's heat, it gets very hot. But at the Terminator, between day and night, the temperature's cooler. So the idea is that maybe life, with the help of technology, could survive there. And that was, I've not read the book, but I have read about it. And from what I can gather, it was, yeah, this convoy of mobile city-states that would stay close to the Terminator where the temperature's cooler.
Yeah, and that's the funny thing about imagining this, because in your book, you imagine, okay, what would these creatures be like? And then I always go back to SETI because it's always confused me. It doesn't say search for extraterrestrial life. It says search for extraterrestrial intelligence. And what that means is, to me, that what we may encounter is like, it's not an unknown, it's an unknown unknown. We have no idea whether the planet itself might be sentient, like in Avatar. You mentioned Pandora.
Yeah. I mean, in Avatar, the Na'vi are obviously intelligent. They have society, but they don't have technology like we do. And there is discussion in SETI circles about whether calling it the search for extraterrestrial intelligence is the best name for it, because intelligence, in the past, intelligence has been equated to technology, and it has quite rightly been pointed out that, you know, going back to colonial times, European powers that had more advanced technology would believe themselves superior to indigenous populations who didn't have that technology. You know, the indigenous populations weren't any less intelligent; they just didn't have that technology. And so that's maybe not the best way to think of life based on based on intelligence, because there's different kinds of intelligence, and at what point do you say something isn't intelligent?
Yeah, and then, you know, you're talking about worlds where the only thing that could probably exist would be cytobacteria or tardigrades, because they can handle those things. But whether they have intelligence, or as some of the people I've interviewed, like Philip Goff, who believes in panpsychism, whether they have intelligence or their very volition is a form of self-awareness, which gets away from the book. But, you know, whether they have an awareness of their own existence, which would be the seat of consciousness.
Yeah.
There's no way we can determine that. You know,
no, none at all. And obviously, you know, if they don't have radio technology or laser technology or something that can allow them to send messages across the stars, we're not going to find them. So we could be missing. You know, there could be whole worlds, ocean worlds, populated by dolphins, smart dolphins. They don't have the appendages to manipulate technology. They could be geniuses, but not have technology, and we would miss them, just because we have this very narrow definition of, oh, intelligence must mean technology, which is rubbish. So, yeah, SETI is not perfect. We kind of look for what we can look for, and if there were other ways, you know, SETI scientists now talk more about, rather than looking for intelligence, look for techno signatures of alien technology, stuff that we can see, whether it's city lights, Dyson spheres, stuff that we have no idea what it's meant to do, but it's obviously artificial. While astrobiologists look for biosignatures, which are gases in the atmosphere that are that indicate the presence of life, oxygen, methane, other things.
Yeah, and that's one of,
but again, they're indirect ways.
Yeah, and that's one of the things when you drill down, and I thought of it when you mentioned seeing cities from the planets to the planets in a red dwarf system. How is it that, and this is something that most people have no idea how we can do it, how is it that we can discover the possibility of water on a planet, or the possibility of a signature of something that might be something that only occurs in the presence of life? How is it that we have instruments so sophisticated that they can do that?
Well, it's all done by spectroscopy, which is like what you see in a rainbow, you know, a prism splitting light into its different wavelengths. And certain gases will emit or absorb at certain wavelengths. So when we take a spectrum, we see either bright emission lines or dark absorption lines, where something is absorbing that. And oxygen, water molecules, carbon dioxide, you know, all kinds of organic molecules, they absorb at characteristic wavelengths. So if we see an absorption line in the spectrum at that wavelength, then we know that molecule must be in that planet's atmosphere. So then we can start to draw conclusions. And you know, you may have seen in the news recently the claim that a biosignature, a gas, dimethyl sulfide, has been found by the James Webb Space Telescope in the atmosphere of a planet called K218b. And this is a biosignature that on Earth is only produced by microbial life. That's not to say that there couldn't be some other processes that don't involve life on other worlds that produce it, but and the signal's still pretty weak. There's a lot of debate, but that's the kind of thing that they're looking for, these signs of the byproducts of life.
And the sign that's most important, and it may turn out to be most important or not, is the sign of water existing on a planet. How do we determine that?
Well, water is very common. So there's this science fiction trope that water is rare, War of the Worlds. You know, the Martians wanted our water because their water dried up. The TV series V, the aliens had come for, besides to eat us and use us as slaves, they wanted our water. So there's this trope that water is rare. It's very, very common. It's made up of oxygen and hydrogen, two of the most common atoms in the universe. So water per se isn't rare. We even find it in Jupiter's atmosphere. But what we're looking for is ocean worlds, really, whether it's a world like Earth that has seas and continents, or possibly a planet that is just covered in an ocean, maybe tens, hundreds of kilometers deep. And you know, scientists' models suggest that such worlds could be really quite common in the universe. So again, it would be looking for a planet in what we call a habitable zone. So this is the distance from a star where a planet's temperature, assuming it has an atmosphere to retain the heat, where a planet's temperature is suitable for liquid water. So if you think about our solar system, we have the two innermost planets, Mercury and Venus. They're too hot to support liquid water on their surface. Venus was right on the boundary, but it's gone the wrong way. Further out, Mars, again, used to have liquid water, but it's right on the outer edge of the habitable zone. And Mars was too small to hold on to its atmosphere, and it very quickly froze and all the water went away. Earth is right in the middle of what we call the habitable zone. And the temperatures here, as we know, are just right for liquid water to exist in large amounts. So astronomers look for planets that exist in their star's habitable zone. And then once they've found them, then it would be this, you know, using spectroscopy to look for the atmospheric gases. So we would imagine a water-rich world to have a very strong signal of water vapor in its atmosphere, just like Earth does. But again, we can't, you know, we can't take a picture and see the oceans yet. Maybe in a couple of decades that would be possible.
Well, it's like in you spend some time on Tatooine, but only for the most part the aesthetics of the suns and the sunset that sees. But you do spend a great deal of time on Arrakis and Frank Herbert's Dune, and you even suggest that there has to be water there, and there is water there. So even on a desert world, there's still water.
Yeah.
And then on the moon, on the moons of the outer planets or the gas giants, there's certainly substantial, if not certain, evidence that there's underground oceans that, as you say, may be kilometers deep.
Yeah, well, absolutely. Europa, for example. The big question over Europa is whether it has the chemistry, the organic chemistry to support life. But just going back to Arrakis, we talked earlier about, you know, where sort of the classic writers got their ideas from, and that they were predicting a lot of things. And I believe Frank Herbert was inspired to write Dune because he'd been a journalist and he'd written an article about some dune fields in California, I think, and it gave him the idea. But it's interesting how similar Arrakis is to Mars. At the time, we didn't know this. In 1965, when Dune was published, we didn't know too much about Mars. We knew it was dry, but we didn't know that it had water long ago. And then when the first spacecraft went there, they saw these dried up river channels and deltas and areas where there could have been seas. And now the modern rovers are discovering minerals and things that have been, you know, created by running water 4 billion years ago. And Arrakis, you know, Herbert, he had this whole appendix. I think it was written as if it was written by Kynes, because in the book Kynes was a geologist, and he had this dream of, in the modern films it's played by a woman, but in the original book it was a he, and he had this dream of bringing water back to Arrakis to make it more habitable again. And this whole appendix, it's literally like reading about a geologist's survey of Mars, not a fictional planet called Arrakis. And it's remarkable how accurate Herbert was in predicting what Mars was like. And I just, the amount of detail that he went into in that book to make the planet feel like a character, it's just remarkable. And it's definitely my favorite science fiction novel.
No, me too. It kind of changed my life in the way because it didn't seem like science fiction, especially when you're talking about appendix. It seemed like, okay, this is, especially when Leto, you know, when he goes from this water world to this place that's barren and desolate. But it reminded me of something lately, and this is far afield from your book, but it's an interesting question. There's all these articles and even a new book, I think, about the potential cultural impact of extraterrestrial contact. And maybe we really shouldn't be looking for it because in all likelihood, it's not going to be good.
Yeah, I touched upon this a little bit in the contact paradox. That's really where the name came from. And think of all the things in human history that have been turning points, have been brought back by technology, like the internet has changed the world. Motor vehicles changed the world. Air travel changed the world. Industrialization changed the world. Agriculture changed the world, not always in ways that we could predict. Now, these were events that, had a human genesis. So imagine meeting aliens and they have technology far in advance of our own and they give it to us. We have no idea how society is going to react to that. Is it going to be good? Is it going to be bad? A technology, imagine Star Trek's replicator that can make anything just materialize. What's that going to do to, industry? Millions of people are going to be without a job because people can just make whatever they want from a replicator. So it's those kind of, when people talk about, oh, we shouldn't go looking for aliens, or we shouldn't send messages to aliens, or we shouldn't reply to a message if we receive one, they're talking about maybe the aliens are going to want to attack us or invade us or eat us or whatever. And to me, that's a bit of a straw man argument, and it's a bit of the real question is how it will affect society. And history shows us that we can't predict how turning points like that, the introduction of new ideas, new technology, will affect society. And it might not always be a good change. Maybe there's aliens introduce a new religion. What happens to all the earthly religions? It's my argument is, let's not go sending messages to get aliens' attention until we at least know a little bit more about what's out there and we can better prepare ourselves.
It's like you mentioned in the bibliography the three body problem, and it's like that. Be careful of what you wish for.
Yeah. I'll be honest, I've only read the first one of those books. I did struggle with it a little bit. But absolutely, yeah, that was all brought about by, it was in China, wasn't it, at the beginning, and the astronomer detected a signal and sent a reply without telling anybody. And that leads to all kinds of trouble.
Yeah, I mean, you talk about how it could affect us. Look at today's world, how fast we've pivoted. There's basically three people that are controlling a good portion of what happens in the world. That's 3 human beings. So no, all these things are unimaginable. And I always go back to Richard Feynman's anecdotes. First of all, he says, let's suppose an alien civilization looks at the game of chess. I mean, maybe you've heard this, and they find everything out about chess and they're sure they understand the game. And then all of a sudden someone castles. This doesn't make any sense. And the other one he does, which is really good, is that the Terminator, you see this Terminator going across the planet and people on the dark side are laying horizontal. Then they rise into a vertical position. They go into a little room that has water and they take a stick out of a drawer and they start going like this.
Yeah.
And the aliens, what the hell are they doing?
Yeah. It's absolutely. But it's interesting just going back to the chess, because that makes me think of artificial intelligence, which at the moment is just an advanced program. It can't think for itself. But, if we were able to create sentient AI, how would that be any different from contact with an alien? It's an alien intelligence, not like ours. And AI can play chess just fine. So, so maybe, yeah. And it works vice versa. We would how would we know? How would we even recognize alien life in some cases?
Exactly.
Very different. We might not notice.
And if in 100 years we have an artificial general intelligence that decides that the Earth would be better with the elimination of one species, us, it would. And then what is our alien? We have our alien life. It goes to the Fermi paradox too, that and also like that any society advanced enough to achieve intergalactic travel is also advanced enough to destroy itself. You know?
Yeah, yeah. I don't know. It's all a bit. Sometimes I find those scenarios a little bit too pessimistic, and maybe it's reflective not of reality but of our current times. The Fermi paradox, Enrico Fermi came up with that in 1951. The Cold War was just getting started. He'd helped with the development of nuclear weapons. The end of the planet was very much, topic of discussion. And he had the whole Cold War. The Cold War had a huge effect on SETI and SETI thinking. There's this great book by Rebecca Charbonneau called, what is it called? Somewhere. Mixed Signals. And it's all about the Cold War's influence on SETI thinking, both in the West and the East. And it had a dramatic effect. And even now, with what's going on in the world, there's lots of worries and fears. And I think that manifests itself a little bit into how we imagine alien life might be like. So I would urge a little bit of caution in worrying too much about all alien life blows itself up or whatever, because that's reflective of our current times and what we're worrying about.
Okay, well, I'm generally fatalistic for good or bad. You seem optimistic. Why is that optimism something that you've adopted? And will your optimism won't be realized during your lifetime in all likelihood?
To answer your first part first, where does it come from? I've read too much science fiction. No, it's true. I don't like dystopian science fiction. I tend to avoid that. I don't. Obviously, certain like the George Orwell stuff is important. It's predictive. It's a warning. But I think sometimes authors kind of revel in the dystopia, and it troubles me a little bit. Although a lot of teen fiction is dystopian. Now, I kind of get that because teens want to be rebellious, and so you can't have a rebel that's a good person unless there's a dystopia they're rebelling against. So I kind of get it. But it troubles me that so much of teen fiction is dystopian.
Well, look, me owning a bookstore, I'd say at least, well more than half, at least 60 to 70% of the science fiction that comes out does describe dystopian situation. And maybe, as you say, it just reflects what's happening in the world today.
But it's also how it's, because when you're writing fiction, you obviously want something to challenge your characters, your heroes. And normally that's a bad thing because they have to have an adversary. And so, for example, with Star Trek, which is, the opposite of a dystopia, sometimes they struggle to find good stories because the human condition was so perfect that the threats were always external then or technological. Whereas something like the TV show Babylon 5, I've heard people describe that as dystopian, and it's not. Yes, there's a dictator and there's all kinds of wars, but it's about how they got through that and create a better world. So I think dystopian fiction that shows the creation of a better world at the end of it, great. But if it's just about showing lots of misery and pessimism and lack of hope, I'm not sure what's gained from that. So that's where I get my optimism from, is from science fiction, that, writers, TV shows, films present these possible futures. And it's something to aspire to. I'm not saying that we could ever have a Star Trek future where, the spacecraft warping to other star systems and everything is perfect, but it's still something to try and strive for.
Yeah.
I don't remember what the second part of the question was.
Well, your answer led to something else. Is like the way you handle Star Trek is, the science is really completely wrong in this episode, but it's a lot of fun.
Yeah.
I was thinking of The Trouble with Tribbles. I mean, it was silly, but it was a lot of fun. Or going back and bringing a whale back because it's, they're more intelligent. Yeah.
But there's different facets to the story. I mean, okay, with the time traveling, getting the whales, okay, and the whales will communicate with this alien and tell it, as I think where Bones said, where to go. yeah, that's silly, but there's an important environmental message there. So there's there's things to take from it and to learn from, which is what I always say.
Well, me talking to Andy Weir twice about the first The Martian, then Artemis, 3 times, and then Operation, I forgot what it's called. It was supposed
Project
to be,
Hail Mary.
yeah, it was supposed to be a movie with like Ryan Gosling and all, but I guess it's gotten can't. I don't. Yeah, he had
No,
movies.
it's still going. I think it's still going ahead.
Yeah, it'll happen. But these movies, after you get optioned, maybe yours will get optioned, but it takes a while for them to get done. But Andy Weir, like the science is really good science. You mentioned it. You talk about, but you do talk about the fact that what was it? The dust storm. What was it that happened that stranded him? What was it? You mentioned it in the book.
That's right. Yeah. So Mars has these dust storms that blow up. They're a seasonal thing. Sometimes they can cover the entire planet and hides all the craters and mountains and things. But the air pressure on Mars is really low. The atmosphere is very thin, so there's not a lot of wind pressure. And so at the beginning of his book, Mark Watney, played by Matt Damon in the film, the astronaut, he's stranded when they're worried that the dust storm is going to blow things over, blow their spacecraft over. So they have to leave, and he's stranded outside. But in reality, the dust storm couldn't whip up enough wind pressure to blow anything over. But so that's a conceit of the story, and perhaps he could have found a better way to leave him stranded. But I'm not sure what. So maybe that was just the best option. He needed to have the astronaut stranded, so he just used that, which is fine. I mean, I talked to Charlie Jane Anders, who's the author of this. Bear with me a moment. The City in the Middle of the Night, which is set on a tidally locked world, and so she talked to a scientist about tidally locked worlds to try and get the science as accurate as possible. But even she confided that ultimately her job was to tell a story. So if she had to fudge the science or ignore the science to make that story work, she would. And we have to remember science fiction isn't it can be used as an education tool, but its primary objective is not to be educational, it's to tell a story. So that's why I forgive sometimes bad science in science fiction if the story it's telling is worthwhile.
Yeah, it's like the authors you do mention, like Charlie Jane Anders, Stephen Baxter, Alastair Reynolds. I was thinking of the consultant on Interstellar. How do they fit into it? How did that come about in your construction of the book, bringing these people in?
It's interesting. So,
sorry. Go ahead.
So, Amazing Worlds, when I began it was always a science book. It's a popular science book at the end of the day. And I wanted to use examples from science fiction just to illuminate what was possible and what isn't. And it wasn't until halfway through writing it that I kind of thought, hang on, I should be talking to the authors here, not just the scientists, but the people who create the science fiction to get their point of view. And I knew Alastair Reynolds and Stephen Baxter from before when I did, actually before the Contact Paradox, actually, I'd met them a couple of times. So I spoke to them, I spoke to Paul Macaulay, and then I was trying to match up authors with different types of planets. And I had a recommendation for The City in the Middle of the Night by Charlie Jane Anders. So I reached out to her and she was very gracious in speaking to me. And I also spoke to Arkady Martin, who
award winner.
Yeah. And
she's really smart. She is very smart.
Yeah. She works in real life. She works in city planning, urban planning. And in her first book, it was set on an Ecumenopolis, which is a city planet like Coruscant or Trantor from Asimov's Foundation. So she had a lot to say about that. She, that's a kind of a social science, I guess, but it's still, she had a lot of knowledge about that and was able to put that in her book. But yeah, it was odd that I set out writing the book, not planning on talking to the science fiction authors. It was only halfway through when I thought, I need to do this. I need to speak to them.
Yeah.
Um,
There were so many parallels. I'm thinking in Interstellar, when you talk about an ocean world and the enormous tide, and then what was the world in Interstellar where they're landing in the water, and then all of a sudden what's that mountain out there, and then it's 500-foot wave.
yeah, yeah, because of the huge gravitational tidal forces of the black hole that this planet's orbiting, and so the science consultant on that was Kip Thorne.
That was a good way for the reader. Yeah, that's the best part of the connection, is that, okay, you describe what would happen on a world like that, and then you can think to the movie and you see it. You see exactly what would happen. It would actually be higher than that.
Yeah, yeah. But I mean, Kip Thorne, who was the consult, he was the person who originally came up with the idea, and it was kind of co-opted by Christopher Nolan, and the story was changed around quite a bit, but they kept him on as a science consultant. And I remember interviewing him when the film came out, and he would relate how the director would say, "I want this to happen on this planet. Make it possible." That's not possible. But the director wasn't having notice. He would have to go away and do all the maths and figure it all out. And yes, it is possible. And so he published a book, The Science of Interstellar, that goes into explaining it all. So that was really fiction driving the science quite literally, because to present a black hole in the movie as accurately as possible, the computer simulations were so advanced, and it used real scientific data, that real scientists actually use that program now to visualize black holes.
Amazing.
Yeah.
Yeah. The other thing is, you have to, in order for you to equate the two things, because we can't possibly do it, you have to resort to wormholes in a lot of novels in order to get to the worlds that you want to describe.
Yeah. Well, I mean, I remember it wasn't, yeah, I was doing an interview for somebody on the back of the book, and they were asking me about the nonsense science in science fiction. And I was like, to me, that does science fiction a bit of a disservice. I mean, yes, there is lots of nonsense science, but there's also lots of science fiction with science fiction writers are very good at taking a scientific idea and extrapolating. So suspended animation is one. Medical scientists are experimenting with a form of suspended animation that can be used in surgery and things like that, or just preserving a body until they can get it to a hospital to operate and things like that. And science fiction writers can extrapolate that and then apply it as suspended animation on a long interstellar voyage. So yeah, you know what, people say that science fiction predicts. It does a little bit, although a lot of science fiction writers would say they're not predictive. But I think what science fiction does well is it extrapolates. Whether it's a planet, whether it's alien life, whether it's a form of technology, science fiction is able to extrapolate from that and look at all the different possibilities that could arise from that.
Yeah, I always thought the 2001 is one of the best movies ever made. I think I saw it 13 times, because all of that the suspended animation, much better than in Passengers. The suspended animation seemed so real, and everything that happened was all feasible, other than, well, all feasible. Even the manner in which technology on Earth from the very beginning to that point was fostered by aliens who were preparing us, and shaping us, which is not so far-fetched at all.
Yeah. Even HAL, I mean, a lot of concerns about AI today probably stem back to HAL. And you asked, what would we rather have, a boring computer like in Star Trek, or one with a personality? I'd go for the boring one. I don't, know. So yeah, if the one with the personality is going to be like HAL, then
I don't want, like today I dictated the introduction I had today, and she's going, "Oh, that was really well done, very powerful." And I'm thinking, "Oh, that's nice of her to say." And then I said, "Can I improve it in any way?" And she changed one of the sentences. She goes, "This is a run-on sentence. You could change that," and it was really well done. And she, mine has a British accent, sometimes Australian, and yeah, it's what's really weird is there's so many people at the bookstore that get angry at me for using ChatGPT, literally angry. and they refuse to even look at it. And I said, you're behind a wave and you better, there's a graphics designer that worked for me. And she says, it has no humanity. I said, you better learn it, because something that takes you a month to do, she can do in 5 seconds and better than you. But there's so many people that refuse to acknowledge its existence. And I think it's mostly based on fear.
Yeah, I'd probably, not through fear, but I would probably side with them, because as a creative, when we talk about AI, it's not like HAL, it's not like data, it's not, it's not a sentient being that can think for itself. That is a completely different thing. This is just an advanced program that has been trained on. I mean, I think it was The Atlantic recently had an article about, I can't remember if it was Google or whoever had, taken this vast library of books. And even had a tool where you could type in your name or your book and see if it had been involved. And I typed my name there, go contact paradox, and some other articles I'd done had been, nobody asked me. So when, somebody asked ChatGPT about SETI, some of my book might be in that answer. And then publishers, they just want to make money. And if they can make more money from an AI writing something rather than hiring a human being, they're going to. But all those creatives who have written those books that have trained the AI don't get anything. We don't get any compensation. We just get put out of work. So from my point of view, I don't like that kind of AI. But again, AI has its uses in solving scientific problems, mathematical problems, medical problems, whatever. That definitely we need AI for that kind of thing. But this kind of, I don't know, I'm not comfortable with this more flippant use of AI, whether it's creating artwork or writing things.
Yeah, but we're going to plan a trip to Switzerland. I said, we're going to land in Geneva. Give me an itinerary for a 10-day trip.
Yeah.
It's a lot better than I can do it. I'm not.
Yeah. And that's, that's just a more advanced way of Googling it.
Right.
And Google, Google's run off AI for ages. Would be hypocrites to say we don't use AI. Every time we do an internet search, we're using AI.
Yeah, but Siri sucks, Alexa sucks. It's a completely different thing.
Yeah.
Talking about computers and HAL and data, the best one is the holographic doctor on Star Trek, because he's just a guy and he has a sense of humor too.
Yeah. And it's because he starts out with no personality. And I guess over the course of the show, his thought routines become more advanced, and you see that personality developing.
Which is what's...
Yeah. And we're same with Data a little bit as well.
And Spock. Which is different, but still.
Well, Spock is trying to go the other way. He's half human, and he's trying to reject that human and go to the more logical, robotic, if you want to say robotic side of being fully Vulcan.
They asked the doctor when he appears, and he always says, "What's the nature of your medical emergency?" And the woman goes, "Do you always have to start with that?"
Yeah. But that's how he's been programmed, and yeah.
Well, I don't know if anyone's going to listen to us for an hour and 10 minutes, but this is fascinating. And the book, because I have a bookstore, it's easy for me. Especially, I looked at the upcoming books from your publisher, and it's amazing. I want to interview every one of them. So it's a wonderful publishing house.
Yeah, in London, it specializes in nonfiction stuff. Some of it's academic, some of it isn't, like mine. But yeah, no, they've been around for a while now. They've published some good stuff.
It's because of your book that I discovered them. So I thank you for that as well.
Yeah, thank you.
But in any event, thank you so much for doing this today. I really enjoyed your book. And what I was saying is a bookseller will be on our front table for a while.
Oh, fantastic. Well, anybody who's interested in science fiction, hopefully, they'll see a lot in it that they recognize in the bibliography, and hopefully they learn some more about science and the process. And anybody who's interested in science, then hopefully they're going to be introduced to some great science fiction.
Yeah, and
that's my hope.
I'm glad that you convinced your publisher to leave the bibliography in, because it meant a lot. Yeah. Okay, thanks so much.
Thank you.
Thank you for joining us for another episode of The Avid Reader. If you liked today's episode, check out more of our content on our channel.